Welcome to the Upcast demo series on pricing and market mechanisms for data assets. In this short sequence, we'll walk through static pricing, dynamic pricing, and a bidding system for auction-style marketplaces, each with a live API demo. The plugin offers three main features tailored to make smarter, data-driven pricing decisions. The static pricing option uses trained models based on key dataset attributes such as volume, type, and category. By estimating prices using comparable datasets, it applies a competitor-based strategy ideal for stable markets. The dynamic pricing feature reacts quickly to market changes, recent events, and price trends. This enables businesses to adapt in real time, helping maximize revenue opportunities while staying competitive. The optimal bidding feature applies advanced mathematical models to recommend bid amounts that balance winning opportunities with profitability. This helps bidder confidently participate in competitive data auctions, even when datasets are limited. If you want access to the resources or plugin, please contact us in this form. Thanks for watching, and let's move to the demos. Welcome to the Static Pricing plugin demonstration. This session showcases the capabilities of the Static Pricing module. In this demonstration, we will explore how the static pricing system estimates the economic value of datasets based on their metadata, how the explainable AI component interprets those results, and how the API can be used by other systems. Let's begin by understanding what we mean by static pricing. When I say static pricing, I mean a stable mapping from descriptive metadata to a price suggestion, no real-time usage signals. This is ideal for catalogs, proposals, early GTM, and internal guardrails where you need consistency and explainability. At its core, the model uses a combination of metadata features such as category, format, update frequency, delivery method, geographic coverage, and various usage or licensing attributes. These descriptors are transformed into numerical representations, which are then passed to a machine learning ensemble that includes both deep neural networks and random forest regressors. For textual fields such as the title and description of the dataset, we use transformer-based embeddings that capture semantic meaning. These embeddings help the model understand similarity between datasets, even when the wording differs. For SMEs, this really hits the sweet spot. Low lift. You don't need to stand up billing infrastructure to get a list price. Predictable. Easy to communicate and budget. Explainable. Sales, product, and legal can all align on the same rationale. No black box. All of this functionality is accessible via a REST API, available at the provided endpoint. Users can access the API documentation and test it directly through the Swagger interface. Let's try it out. Before executing any request, authentication is required. Use the Authorize button, provide your credentials, and log in. Once authenticated, you can try any of the available endpoints. Let's have a look at the Get Price Range endpoint. Here, you need to provide the dataset metadata in the expected JSON structure. Each record includes attributes in their properties such as title, description, category, file format, update frequency, delivery type, geographic scope, licensing model, and additional flags like whether the data is real-time or includes session tracking. Most fields have predefined values to ensure consistency. Once all fields are filled, simply execute the request. The model runs the prediction and returns the estimated price, together with additional metadata in JSON format. Let's look at the response. The output contains the estimated value of the dataset in a range, minimum value, average value, and maximum value as per the different models used in the estimation. For interpretability, we use the SHAP method, which identifies how each feature contributed to the model's final decision. Let's try it in the Get Explanation endpoint. The input will be the same as in the last one. Positive SHAP values indicate that a feature increased the predicted price, while negative values show a decreasing effect. Below the numerical results, The interface provides a readable explanation summarizing which attributes had the highest positive and negative impact. For example, datasets with broader geographic coverage or more frequent updates tend to receive higher predicted values, while limited access or restricted license datasets typically lower the estimated price. This human-readable explanation helps users and data providers understand not just what their data is worth, but also why it was valued that way, enabling them to make improvements to metadata or accessibility to enhance market value. You can see several fields where there's an increase or decrease of the price because of a specific feature. In summary, the static pricing plugin offers a transparent, explainable, and easy-to-integrate mechanism for dataset valuation. It supports consistent pricing decisions across organizations and provides the necessary interpretability for compliance and auditability within the European data economy. That concludes the demonstration of the static pricing plugin. Thank you for watching. Welcome to the Dynamic Pricing Plugin training session. This session is brought to you by CEDAR, Ireland's National Centre for AI. In today's training, we will look into Dynamic Pricing Plugin, why this is important for businesses and enterprises, and we will end our session with a live demo. Dynamic pricing could be considered as a strategy that involves rapid adjustment in prices of products or services. This is in response to various market forces, such as demand and supply, or broader geopolitical and economic events. While static pricing maintains a fixed price regardless of market fluctuations, dynamic pricing provides flexibility by responding swiftly to changes in market conditions. On the right-hand side is the overall architecture of our plugin. If we consider top-down flow, we can observe that the trend and event information is retrieved from public sources. This data serves as the foundation for periodically training and validating our predictive pricing model to ensure it stays accurate and relevant over time. When ready, this model is served via REST API, and our clients or users could access it via Swagger interface. This interface is basically a collection of API documentation and resources. Now, why does this dynamic plugin matter for enterprises and institutions? Our dynamic pricing plugin could be an important contributor for small or large enterprises. This is because, first, with our pricing plugin, you can maximize your revenue by strategically increasing prices during high demand and lowering them during slow periods. This not only helps to maintain stable inventory, but also balances demand and supply of the product. Second, it expands market adaptability and competitive advantage by enabling your organization to quickly respond to competitors' action and market changes. Third, it helps to establish customer trust by adopting transparent, market-aligned pricing that ensures fairness. And finally, the automated API-driven nature of our plugin allows businesses to be as responsive as larger players without manual price review and enables easy integration without bigger technical teams. With this, let's look into the demo of Dynamic Pricing API. You can access this page from the provided resources. Once you are on the page, you have to be authenticated. You can do so by simply using this Authorize button. As the form appears, provide username and password and click the Login button. Since I'm already logged in, I'm skipping this process. However, if you want to try it out yourself and need a username and password, please use this form, provide us your details, and we will get back to you as soon as possible. Now, to use these endpoints for the dynamic pricing, you have to provide some information in a predefined format. That format is composed of specified numbers of attributes which are listed here. First is the identifier of the dataset, title of the dataset, dataset description, category, file type, available for user, content type, subscription type, frequency of the dataset update, or the interval at which the dataset is updated, geoscope or number of countries that are represented in the dataset, access type or delivery method, traceability of the data sources, or if the source is traceable or not. Does the dataset have a missing value or not? File size in the gigabyte and data license. Note that most of this field has predefined inputs, so you need to make sure that your value is the closest match to the provided values. If they are not in the list, select Others And if you are not sure, then select Not Available. So with this, once you have all the input values, you can try the endpoint. Here, we have provided an example with all the possible attributes. And to try it out, we will simply execute it through this button and check the results. Our result is also in JSON format. It includes estimated value of the dataset, currency, model that was used for estimation, explainable AI method used for our model, and its introduction. We use SHAP method and its introduction here. The explanation provides detail on the contribution of the attributes. For example, the negative value here represents the negative impact on the average output, and the positive value here represents the positive impact on the average output of the model. We also provide the human-readable text in the overall explanation part, where we highlight the attributes and their contribution in percentage. For instance, here you can observe attributes that have the strongest negative impact, the attributes that have the strongest positive impact, and the attributes that could be improved to increase the value of your dataset. That's all for the demo. I hope you enjoy it. Welcome to our tutorial on using the optimal bidding feature to win auctions smarter and save you money. This tutorial is presented to you by CEDAR, Ireland's National Centre for AI. Today, we'll explore how this tool helps you place the perfect bid in auctions, why it's particularly valuable for small and medium enterprises and institutions, and then walk through a live demo. The optimal bid is a strategy designed for auction-based pricing, where buyers compete by submitting bids and the final price is set by the auction outcome. In this context, our tool helps you calculate the ideal bid for a single auction by balancing two key goals: maximizing your chances of winning while avoiding unnecessary overpayment. It uses probabilistic model to analyze bidding behavior, providing you with smart, data-driven recommendations for sealed second price auction. So, why is this optimal bid system being important for small and medium enterprises and institutions on the context of datasets auctions? First, it helps buyers use their budget wisely by calculating the best bid to win without overspending. Second, it analyzes bid data securely with probabilistic models, protecting privacy by not storing sensitive information. Finally, it enables small businesses and institutions to make smart, timely bids in fast-paced dataset auctions. Now, let's move on to the demo of the Optimal Bid API. The REST API documentation follows OpenAPI standards and is presented through a Swagger interface. This system lets you both test the API and easily understand the required input parameters and the expected output formats. If you'd like to try it yourself, please reach out to us using this form. Once we receive your request, we will respond as soon as possible. The API is protected. You need to authenticate to try out the endpoints. There are two endpoints available. One provides an example of historical data, and the other returns the optimal bid. In this demo, we will focus on the optimal bid endpoint. You need to provide as input your valuation of the dataset or the maximum budget you can allocate, the current listed price, if there isn't one, enter 0, and the bidding historical data for similar datasets as a CSV file. Detailed instructions about the CSV file format are provided at the top of the Optima Bid documentation. Once you provide the input to the endpoint, click the Submit button. The output presents the results of the bidding strategy analysis based on a mathematical model using your historical bid data as the unit of measurement. 3 optimal bidding scenarios are identified, each with a distinct strategy, winning probability, and recommended bid amount. Scenario 1 follows a high-reward, high-risk strategy. Scenario 2 takes a balanced approach. Scenario 3 emphasizes win-focused, less gain. Strategy. You can now choose the strategy that best fits your goals. If you want to try it yourself, please contact us using the provided form, and we'll get you set up. Thank you for joining this session. I hope you found the optimal bidding system useful to boost your auction success. This pricing plugin supports several key use cases. For example, It enables data providers to set competitive, market-aligned prices. It also helps bidders in data auctions with strategic bidding and bid optimization. Additionally, companies can automate pricing for managing large sales volumes. Finally, it offers explainability features to ensure transparent and auditable pricing decisions. These are just some of the ways this plugin can be used. The pricing plugin delivers a secure, flexible approach to optimize pricing and bidding, featuring a modular design for easy integration. It meets Upcast AI trustworthiness standards across fairness, transparency, safety, privacy, human oversight, environmental impact, accountability, and robustness. Thank you for joining this session. I hope you found the pricing plugin useful to boost your pricing strategy's success.